Now let's take a look at Avogadro's number and the mole. So here I've written the equation for the combustion of ethylene, C2H4. So I balanced it out and everything, and hypothetically, let's say the mass of these two added together is 500 grams, and the mass of just the ethylene, C2H4, is 200 grams. So the law of conservation of mass tells us that the mass of the reactants has to equal the mass of the products. So it is true saying that if this is 500 grams, this must also be 500 grams. Unfortunately though, you can't say that because we have 200 grams of ethylene, we have 200 grams of carbon dioxide, or even saying we have 200 grams of water. Mass does not equal mass when we're trying to balance it out. However, we can use the chemist's version of the baker's dozen, the mole. So instead of saying 1 gram of ethylene reacts to give us 1 or even 2 grams of carbon dioxide, because you see the 2 over here, we can say that 1 molecule of ethylene reacts to give us 2 molecules of carbon dioxide. That is true. But when we're looking at gram amounts, we have billions and trillions of molecules. So it wouldn't be easy for us to say 5 trillion molecules of ethylene react to give us 10 trillion molecules of carbon dioxide. Instead, we use the mole. So 1 mole of any substance has 6.02 times 10 to the 23 molecules. This allows us to talk about large quantities in smaller numbers. So let's do an example. We have a teaspoon of salt and it has 1.8 times 10 to the 22 molecules of sodium chloride. We can determine how many moles that is. So the equation is really easy. It's just N, which stands for moles, equals the number of particles divided by Na, which is just Avogadro's number. So the number of moles is equal to 1.8 times 10 to the 22 divided by 6.02 times 10 to the 23, which gives us 0.03 moles. So we can also get the number of moles from the mass of the compound. The only thing we need is the molar mass. So the molar mass can be easily obtained from the periodic table. All you have to do is add the atomic masses of all the atoms in the compound. So for example, let's figure out the molar mass of CO2. So CO2 has 1 carbon atom and 2 oxygen atoms. According to the periodic table, the mass of the carbon atom is 12.01, the mass of the oxygen atom is 16. So if we do the math, we get that 1 CO2 molecule, or the molar mass of the CO2, is 44.01 grams per mole. This is the unit for molar mass, grams per mole. So if we want to figure out the number of moles in a sample of carbon dioxide, we need to use this equation right here. So N, which stands for the number of moles, equals the mass divided by the molar mass. So if we have 100 grams of CO2, we can figure out the number of moles in there. So 100 grams of carbon dioxide divided by the molar mass, which is 44.01, is not equal to 2.27, but is equal to 2, because we need to remember our significant digits. 100 has only one significant digit, the 1. The other 2 zeros are just placeholders.